So the first question is, and when you look at the solutions, each time the first thing I've done to start off with is to actually say whether or not the order matters and whether or not we're using all or some of the items, okay? To try and get your thinking working in terms of which way you're going with permutations and combinations. I've also got some questions in there that I'll show you that we can use from a binomial approach as well. So, you've got 6 students. I won't read their names, but they're to be seated in a row on the stage for an assembly. So, they're asking, because they're sitting in a row on assembly, then what they're saying is that that's suggesting that the order matters. Okay? So, the next question, if the order matters, is, are we using all or are we only using some of the items?
All.
We've got 6 people and all 6 of them are sitting on assembly. So we're using all. So, when the order matters and we're using all of them, then is that a permutation, combination, or just a straight factorial notation? Right, so we're going with factorial notation. Alright, so that's what I want you to do when you're going through these questions. Ask yourself, does the order matter, does the order not matter? If the order doesn't matter, it's straight up a combination. If the order matters, then you're talking either permutation or just the factorial notation, and then that's dependent on whether you're using all or some. So in this case, we're using all of them. So for part 1, it says in how many ways can they be placed if there are no restrictions on where they sit. So we're using all of them, and it's going to be 6 factorial ways of arranging them. That's a number that Brandon has stored in his head. He pulled out 720 the other day as well.
Factorial is 120.
Yeah.
There's 7 factorial like that.
Okay, so then we get on to questions that now have some restrictions. We're still using all 6 people, so we're still going factorial notation. But it's now saying 2 particular students, Andre and Mitchell, insist on sitting next to each other. So we've got, there's Andre and Mitchell boxed together. And then I've got 1, 2, 3, 4 extra seats to fill. Okay? So, what we've got to do is treat these guys, this box of Andre and Mitchell could equally shift along one and look like this. And then I've still got the 1, 2, 3, 4, 5, 6. And it could move along again. But the issue is it's got to stay together. Boys. So, therefore, you've got to treat this as 1, 2, 3, 4, 5 factorial ways of arranging them. But Andre doesn't have to be in the first seat and Mitchell doesn't have to be in the second seat. So then they can rearrange themselves. They just have to sit together. So there are 2 factorial ways of arranging those people together. Alright? And if you do that, the answer is 240. Okay? So whenever you've got people wanting to sit together, say there were 3 people that wanted to sit together, you'd box the 3 people, and therefore you'd have 1, 2, 3, 4 factorial times, but now there's 3 factorial of ways of arranging them inside that box. Okay? Okay, so then, part 3 says 2 particular students, Alex and James, refuse to sit next to each other. This is
Separation.
yeah, Alex McCritchie and James Humphreys. They used to always fight with each other, so they had to be separated. Okay, so, yes, Jake, do you want to say something? Yeah, in this case, the only thing that can't happen is that the 2 boys sit next to each other, right? Now, we know how many ways there are of sitting 2 people next to each other. We also know how many ways there are of just arranging them in any way whatsoever. So, for this particular one, it's just going to be the total number of ways you can arrange them with no restrictions, minus the only situation in which two people are sitting next to each other, which is the one we worked out above. You can't work out all those, like it'd take forever to work out all those other combinations. Because you could have them separated by 1 seat, you could have them separated by 2 seats, you could have them separated by 3 seats. There'd be lots of ways of having to work that out. But in this situation here, we know that the only thing we don't want is for them to sit next to each other. That's the number of arrangements of all the different combinations of people sitting next to each other. So do that minus the only time when they're next to each other, and that tells you that you've got 480 ways. Okay? Any questions? All right. Okay, so for the next question, you've got a committee. As soon as you see the word committee, what should that tell you that you're looking at? Combination. As soon as you see the word committee, team, it's saying the order doesn't matter. Okay? So that's already telling us that we're talking about a combination. But let's continue to read on. A committee of 5 is to be chosen from 8 Labor Party members and 4 Liberal Party. It is necessary that there is a majority of Labor, but there also has to be at least 1 Liberal Party member. So, how many ways can the committee be chosen? So, for starters, because the order doesn't matter when you're selected for a committee, you're either on the committee or you're not on the committee, then we're using a combination. Now, for this particular question, we've got 8 Labor members and we've got 4 Liberal members. We have to have 1 minimum Liberal member. Okay? If I had 1 Liberal member, how many Labor members would I have?
4.
I want to have a committee of 5 people. So I would have 4 Labor. But I could have 2 Liberal, because it says at least 1 Liberal. If I have 2 Liberal, how many Labor do I have? 3. Okay? Could I go as far as having 3 Liberal?
2.
If I have 3 Liberal, how many Labor? 2. And I must have a majority of Labor, so that one won't work. Okay? So, to work out for that one there, I'm choosing 4 Labor people. From how many did I have to choose from? I had 8 Labor members to choose from. And, and, I need 1 Liberal member from a possible how many? 4 Liberal Party members, okay? I want to get 5 altogether. So that's the 4 plus 1 makes my 5 altogether. Now, that's one option. Remember, then I'm going to say, or I could have had 2 Liberal and 3 Labor. What do I do for or? I do plus. Okay? And so for this one, I could choose 3 Labor from a possible 8 and 2 Liberal from a possible 4. Alright? Yes, Colin?
Why can we get AC2 multiplied by 4C3?
Sorry, say that again?
Just now I didn't understand why shouldn't we choose AC3 multiplied AC2 multiplied by 4C3?
This one?
Yeah.
Because it says there must be a majority of Labor Party members. That means more Labor than Liberal. And this one has less Labor than Liberal. So I was looking at all the different ways we could put them together, but this doesn't work because I don't have a majority. Make sense? Okay? Any questions on that one? We good? Alright.
I wouldn't even read that part of the question.
Okay, next question. And then I might... Oh, no, I'll do the next one as well. Okay, so the next one says, in how many ways can the captain and vice captain be chosen from 10 candidates? And then they've listed off who the 10 candidates are. Now, for starters, if you're talking about captain and vice captain, we've changed from a committee in which you're either on the committee or you're not, to now having a position associated or a hierarchy associated. So captain is different from being vice captain. So therefore the order matters in this particular instance, okay? So the order will matter, and therefore we're down to either permutation or factorial notation. So the next question is, am I using all of the 10 candidates or only some of the 10 candidates? Because I'm only choosing captain and vice captain. I'm only using 2. If I'm only using 2, then I'm talking about a permutation. I'm not using everything. Okay? So, part 1 says, in how many ways can captain and vice captain be chosen? There's no restrictions. So I'm doing a permutation. I want to choose 2 people from a possible 10.
Yeah.
And if I do that, I get 90. 90 different combinations or arrangements of captain and vice captain.
I did 10C1 times 9C1.
And you get it?
Yeah.
Yeah.
Is that okay to do?
So, yeah, so what yours... Yeah. So you're saying the first choice is for my captain. How many can I choose from there? Once I've locked that in, then what's my next choice? And that'll work. That'll work. Yeah.
How about using 10 minus 1 in a bracket multiplied by 10? Also get 9.
Yes, so you're doing it like, well, and that's what permutations are. So you're saying I've got 2 positions to fill. How many people could be captain? 10. I've got 10 to choose from captain. Once I've done that, I've then got 9 left to choose for vice captain. That'll work as well. Okay? So part 2. Now this is a probability question. We want the probability that Jovi is captain and that Hayley is vice captain. Okay? Now, how many different arrangements can we have of Jovi being captain and Hayley being vice captain? 1, right? There's only one way that can happen. So remember we said it's our restricted number over our unrestricted for probability. So there's only one way Jovi can be captain and Hayley vice captain. What was our unrestricted number?
90.
The 90 up above. And that's what takes it from just an arrangements question into a probability question. And where I've talked about the number of restricted arrangements you can have over the number of unrestricted arrangements.